Rock, paper, scissors is a common algorithm challenge that's often given in job interviews. This video demonstrates a test-driven approach to writing a rock, paper, scissors function in JavaScript using the Mocha test framework and the Chai assertion library. Here you can see the final result. A rock, paper, scissors function is in the upper left-hand corner, tests are on the right side, and the terminal, where we'll run the tests, is in the lower left-hand corner. Let's take a step-by-step look at how to get to this final result. The Mocha test framework runs in a Node.js environment. We've got a file named rock, paper, scissors that exports a module. We export a function that we'll call with two arguments. We define parameter A and parameter B to represent what our two players choose. A can be rock, paper, or scissors. B can be rock, paper, or scissors. The test file is named rockpaperscissors.spec, and it's in the same directory. I like the convention of naming test files with a .spec suffix and keeping them right next to their module in the same subfolder. It's a great way to keep code organized. Looking at the test file, on line 1, require the rock, paper, scissors module and store it to a variable. On line 2, require a node package called Chai that I've npm installed. Chai is an assertion library. I'm using expect, which is one of the styles Chai offers. I like expect assertions because it's one of the ways to write tests in a style that reads like English. Looking at line 4, I've wrapped my tests in a describe block. I've got other tests in this project that I'm not concerned with right now, so I'm using .only to say only run the tests inside of this block. Describe is just a function for organizing tests. We pass it two arguments. The first is a string describing the block. The second is an anonymous function for Mocha to run. The first two tests we have are smoke tests. These tests just let us know that everything is wired up correctly. Here, we assert that rock, paper, scissors should exist and that it should be a function. I'm using gulp as a task runner. I've configured a task called Mocha to run my unit tests. If we enter gulp Mocha in the command line, we can see that the two tests we have so far pass. Now that we're set up, we're going to start a loop of writing tests and writing code. My function should return tie when both players play the same thing. Let's write tests for these conditions. Let's run the tests, knowing that these three new tests should fail. Mocha shows us what tests failed. It also gives us some context indicating where the tests failed, what we expected to happen, and what actually happened. We see expected undefined to equal tie. The next step is to write enough code so that our function passes these tests. I've added some lines to the function that should make the tie cases pass. But before we run the tests, let's take care of this linting error. I'm using an ESLint plugin. It's letting me know that my function needs a consistent return. Because there's a return statement inside of an if block, the function needs a return statement after the if block. For now, let's just return false so that our linting error goes away. Let's run our tests again and see that they pass. We've completed one iteration of the write tests, write code loop. Let's start a second iteration by adding tests for conditions where player A wins. Let's run the tests again, knowing that these three new tests will fail. Mocha shows us some details about the test failures. We see expected false to equal A. Let's add some code to make these tests pass. There are three ways that player A can win rock, paper, scissors. Now, we'll run the tests again using the gulp Mocha command. We can see that the tests we have so far all pass. This completes another iteration of our write code, write tests loop. Let's start our third and final iteration by adding tests for conditions where player B wins. Let's run the tests again. We expect these three new tests to fail. Mocha shows us what failed with expected false to equal B. Let's finish up by modifying our code so that our newest tests pass. Now it looks like we expect B but we get false. So what happens if we just change false to B and run the tests again? Our failed report says expected paper to equal B, expected scissors to equal B, and expected rock to equal B. So what's going on here? Right now we're returning the variable B, which changes based on the input. What we need to do is return the string literal, in quotation marks, B. So let's change this B that's actually a variable name to B in quotation marks. Now this is a really easy mistake to make, but we catch it easily because we're writing tests first. Run the test again and we get the same result. Three failing tests here with the same messages we just saw. So what's going on? Turns out I didn't save the file. You can tell by the blue dot on the tab. It tells us we're looking at a file that was modified but wasn't saved. Save the file, run the tests again, and they all pass. The code has passed the tests and met the requirements, so technically we're done. We could continue by refactoring this code or finding other, more elegant solutions. But this, at a minimum, gives us the confidence that our code works. After a quick review, I'll show another possible solution for a rock, paper, scissors function that's a little clever. To review, we set up our environment, a function file, and a test file. We used smoke tests to make sure that we wired things up correctly. And we wrote tests in 3 categories: ties, A winning, and B winning. Along the way, we went back and forth between writing tests and writing code. To finish up, let's consider another possible solution for the rock, paper, scissors algorithm challenge. The solution on the right uses an object called defeaters. The defeater of scissors is rock, the defeater of rock is paper, and the defeater of paper is scissors. We've got 2 conditionals. If A is the defeater of B, return A. If B is the defeater of A, return B. Otherwise, return tie. It's a clever solution, but I don't feel it's as readable as the solution on the left. An advantage to the code on the right, however, is that it can be easily extended. Look for another video with an example of how to extend this defeaters object for the game Rock, Paper, Scissors, Lizard, Spock. Thanks for watching Unit Testing Rock, Paper, Scissors with Mocha and Chai. This has been Eric Carraway.